Hi friends, welcome to Krishang Talks. How are you all doing friends? I hope you all are doing great. In this video, we're going to talk about the late Chateliers principle. So this principle states that if you apply a change to a chemical equilibrium, then that chemical equilibrium will act in such a way that the change you apply to the equilibrium, it will be reversed. For example, if you increase the pressure of the total system, then the equilibrium will act in a way such that the pressure of the system will decrease. That means it will move in a direction where the number of moles is less, because number of moles is directly proportional to pressure. So that means if the change in number of moles is more, that means the number of moles in the products is more than the number of moles in the reactants, then the equilibrium will move towards the left side. That means it will move backward. If the change in number of moles is less, that means the reaction will move in forward direction. So this is Le-Chatelier's principle in pressure. So what if they ask in terms of volume? If the volume is increased, then what will you do? If the volume is increased, then the pressure will be decreased. From volume, you can find out the pressure, and from pressure, you can find out how the equilibrium changes. So let's see how it changes with respect to temperature. Let's say that the reaction is an endothermic reaction. That means it will absorb heat. So if it absorbs heat, then if you increase the temperature, the reaction will move in the forward direction. And if you decrease the temperature, the reaction will move in the backward direction. The reverse is the case for exothermic reaction. If heat is released, if you increase the temperature, the reaction will move in backward direction. And if you decrease the temperature, the reaction will move in the forward direction. This is the case for the exothermic reactions. Now let's talk about another topic, which is the equilibrium constants. There are two equilibrium constants, which are Kc and Kp. Kc is the equilibrium constant with respect to concentration, and Kp is the equilibrium constant with respect to pressure. Now, Kc can be defined as the concentrations of the products to the power the stoichiometric coefficients by the concentration of the reactants to the power the stoichiometric coefficients. Now, Kp is nothing but the partial pressures of the products to the power the stoichiometric coefficients by the partial pressure of the reactants to the power the stoichiometric coefficients. So this is about Kc and Kp, and the relation is important. That relation is that Kc is equal to Kp into RT power Ng, where Ng is the change in number of moles.